Hey everyone, I had not initially planned to do another video for this experiment, but then I remembered we haven't actually done a melting point together yet. So I'm going to show you how to prep the sample and then actually measure a melting point. So the first thing we need are these little glass capillary tubes. So they're called melting point tubes, but all they are is just sealed glass capillary tubes. These are the size that we use. You always want to make sure you use a size that's compatible with the melting point apparatus you're using, but for the most part, they're a fairly standard size. So what's going to happen when we take the melting point is we need to get some of our sample into the bottom of this tube. That's why we need a closed end. And what's going to happen, we're going to put it inside of our melting point apparatus. Meltemp is the kind that we use, so I'm going to just call it a Meltemp from now on. It's going to heat up around where the sample has been inserted, and we're going to just watch the temperature rise on the temperature probe. When our solid turns to a liquid, we have our melting point. So to set it up, it's very simple, not super special at all. You just need to get some of your sample into the bottom. It's a pretty small opening. I don't have a special like micro spatula or anything. You just tap it a few times, get some solid inside of your tube, and then tap it until you get it to go to the bottom. Depending on the type of solid you're working with, this can be a slow and tedious process. So there are a couple tips I have in case you run into issues. This one, for the most part, seems to have gone pretty easily. Most of the solid, minus some that's still coating the sides there, has gone down into the bottom, and you want to try to pack it as evenly as possible. So this one, I'm going to say, is all good. Probably only needed half as much solid as I got in this one, so I'm going to try to get less in the next one. So I'm going to set that aside. This was for compound A, so I'm going to set that aside with it, trying not to spill it. And I'm going to do the same thing for sample B. So new melting point tube, get some in there. Sometimes this can be a little bit more difficult. You see a lot of it's just sort of being pushed around instead. Compound A was a nice fluffy powder, kind of like a fresh fallen snow. It was a lot easier to get in. Sometimes you have to kind of twist the tube a little bit, catch a piece and get it in there. But then again, once you have some in there, you can do this. Let's say you have some stuck at the top because it's a sticky solid or you've packed it very tightly. What you can do, just take advantage of gravity, set up something you can drop your tube through. You can get like kind of cool special looking hollow tubes and everything, but something we all have in our drawers are condensers. You let it bounce a couple times and all the solid is going to very quickly move to the bottom. So that's another way to do this a little bit faster. So this was for sample B. Again, I'm going to set that aside. Now we have sample C. This one might be a little harder. These are very, very thin plates, but I think I'm catching some each time. You can always add more, so you can get a little bit in there, see how it's working. You can always get more into the bottom. Okay, so again, these didn't go too bad. So this one's C. So I'm going to line them up real quick without mixing them up because I want to identify them based on melting point. So it's very important that I do not mix these up. We've got A, B, and C. Looks like I got about the same amount for all three of them. Again, I probably could have done with less, a third less maybe, but we'll just see how it goes and see if we have to retake it or not. Although this is a sample that we're not going to get back, so I've lost the sample that I'm working with here. You can see it takes a very small amount, so you can retake melting points. It's not the end of the world. So I'm going to pause here and reconvene back at the Meltemp. All right, hey guys, I am back with you. You cannot see my face, but what you can see is the temperature probe on our Meltemp apparatus and where the samples are going to go. And then in the second little window, you're going to actually see where the samples melt. So we would typically be looking in here. I've placed sample number 1 in, so that's unknown A, mainly so that I can make sure I line them up in the correct order. So I'm simply inserting the sample down into these slots. I have to do it just by looking in through a little slit at the top, so I can't always gauge which slot I'm putting in, so that's why I check the viewer, but I've got them from left to right, A, B, C inserted now, and I'm gonna start heating it. So first thing, my temperature probe is not actually inside of it, so it has its own little holder that it's gonna go into. I suppose theoretically you could just use a thermometer, but we're going to be going to potentially pretty high temperatures, and we prefer the digital probes. And so we can see what it's reading. It's a little bit warm right now because when I turned it on earlier to look at it, I forgot that the dial was turned up to a heat setting. So it's not very, very hot, about 30 degrees. None of our stuff melts below 100, so I'm not real concerned about it. So I'm going to go ahead and I'm going to start heating up the sample. I'm going to set it at kind of a medium-low setting, so maybe start between 3 and 4. Each melt temp is a little bit different, so got to kind of check it as it's going. And I'm just going to keep an eye on what's happening. Because I can't actually see the viewer, because I'm recording it for you guys, I'm going to just watch how fast the temperature moves, and I'm going to wait until I reach the top cutoff of the expected melting point. This is why our notebook's so important. We want to know when we expect our samples to potentially melt. So we know that we have one of 3 compounds in each of these tubes, but we don't know which is in which one. So we need to figure out what's the lowest potential melting point, which I think is somewhere between 110, 120. I'm going to go check my notebook. And we want to keep an eye on it, and when it gets close to that, so within about 15 degrees, we want to make doubly sure that we've got Hawkeyes on our viewer. In this case, it's being recorded. I cannot see the preview of it, so I won't be able to comment on it, but I will know what to look for when I go back and look at this. So I'm going to grab my notebook real quick. You guys just keep an eye on that for me. Oh, you can see me over here. You can kind of see my face. Hello. Okay. So according to my pre-lab, we expect samples to start melting at 113, 121, or 161. So don't need to be too concerned until we get close to 100 degrees. I hope I'm not obstructing now. Okay. So you can start the melt temp at a higher temperature or a higher setting to start with, because we don't expect anything to happen for the first 100 degrees. We don't need to sit around for 15 minutes waiting for it to slowly heat up to 100 degrees. So that's why I've set it at kind of a medium setting. I could technically be setting it to go a little faster, maybe about 1 degree per second. However, with these older model of melt temps, you can have the setting set so it starts heating up very quickly. But if you want it to slow down all of a sudden, it doesn't have a very fast response time. So I'd rather keep it at a nice steady medium setting instead. So I am going to just hang out and watch it go. I will start speaking again when something should maybe start happening. And if you, like me, are worried about my webcam melting, yes, I am keeping a very close eye on it, because that's a bit of a risk, rubber banding it straight to the melt temp tower though. But this cage around it covers up the heating element, so the older ones didn't have this piece. So the heating element, oh no, I hope I didn't ruin that. Whew, technical difficulties. Okay. It's back though, should still be recording now. I bumped it, was worried I knocked it out of focus, and then when I stopped, it stopped showing me any videos, so I had to reset. But nothing has happened yet, and we're a lot closer, so you just got to save a couple minutes of your life while I frantically tried to figure out how to fix my webcam. Okay, so what we are looking for is the melting point. That means we are looking for the point when the solid pieces that we have inside of our tubes start to become liquid. They don't always happen over the course of, that's what you did, okay. I'm gonna, ooh, ooh, you guys. Okay, sorry, I need to reevaluate what's happening with sample A real quick. I'm gonna slow this down just in case. All right, I'll probably retake this better, but I wanted you to get the chance to actually see it happen if possible. Okay, whew, there we go, it's in there. We'll see if sample A immediately starts melting, then that means I'll probably need to redo it. I was not sure, so I saw a gap in the solid between the bottom, and I did not know if that meant it had started melting or if that meant that I didn't pack it down all the way at the bottom. So I pulled it out. I saw maybe a little liquid. Maybe there's some water left in there. Who knows? I'll have to check back before I can comment on that. But okay. First melting point is 113. Because this is an experimental sample, you want to start looking anywhere 15 degrees before that. So it's very possible that sample A that I was messing with might already be melting. Maybe it's B, maybe it's C. Where's my notebook? We don't know yet which compound is which one. That's what we're attempting to find out. I left it right here. So what you want to take note of is at what point is the first compound, does it first start to melt? And then you want to watch it until all of the solid has melted. So melting point is a range. It might take place over 1 degree, so it might be very fast. It might be like half a degree range, starts melting, done melting very quickly. Or it might start to melt. You'll see the solid kind of resettle a little bit. A little drop of liquid shows up somewhere near the bottom or on the side. And then maybe it stops doing anything for a degree or two and then continues. And then there's a little bit left. And then finally, it all melts. Typical literature values take place over 1 to 2 degrees, possibly even 3 degrees. I think 2 degrees is the typical range max that I see. So that's why if you did your pre-lab for this one, you would see that, let's see, Ben's annelid has a melting point of 161 to 163. That means even a pure sample is expected to melt over a couple of degrees. So the point of this is anytime you take a melting point, make sure that you are writing the start temperature and the stop temperature. It is a range. It will not be just one number. It needs to be the whole range that you record. I see that my temperature has stopped moving. That means my setting is too low, so I'm going to bump it up so it keeps going. By now, one of them should be starting to melt if it has not already melted, or it should be getting ready to melt. Again, from left to right is A, B, and C. So that's moving. I'm going to let it keep going now. One final time from left to right, we have A, B, C. The potential melting points are starting from the lowest 113 to 115, then 121 to 123, and then 161 to 163. So those are the ones that we want to look out for. I'm going to sit very far away so I can't mess the setup anymore. So we're now above the melting point for whichever one is a seat and a lid. So we should be potentially seeing a second one start to melt. Our next one is 121. We're at about 119. So again, it may have already melted. Experimental ranges can be right on. They can be a couple degrees low. They can be 10 degrees low. All depends on the quality of your sample. That's why melting points, while giving us very valuable information, are also very tedious because we are watching by eye what is happening. We don't have a robot that tells us. So we've hit 123.6 now, so the second sample should have melted. Whichever one, again, A, B, or C, belongs to the melting point. That is 121 to 123. So if things are as we hope, again, I cannot see it right now. I can but wait and watch the temperature probe move. 2 should have already melted, hopefully over short ranges and hopefully close to one of the 2 potential literature values. And now we need to heat up to 160 or so. So I'm going to bump the setting up a smidge more to about 4.5. So with these older melt temps, if you ever have the opportunity to use one, the temperature dial does 2 things. One, it controls how fast it's moving. So the higher you set it, the faster it's going to move. It'll jump a couple degrees per second or 0.1 degree per second, depending on how you're modulating it. But sometimes, especially at higher melting points, you'll see it stall out. It'll hit a temperature and it'll just stop. I believe, just based on experience, that you've hit the max temperature that it will go to at whatever that setting is. So if that happens, you just bump the dial up a little more. You can see I bumped it up from just under 4 to just over 4, and it didn't immediately shoot up 20 degrees or anything. But again, you just gotta keep an eye on it and mess with it a little bit. Newer digital ones, I believe you can set an actual rate of heating, so you can ramp it up and then it'll go slower, closer to the one you want. The value of it going slower is that you increase your accuracy there. You don't overshoot your melting point. You don't have to redo it. So in like a classic laboratory scenario, you have no idea what your solid is. You don't even know when it should melt. Instead of letting it go oh so slowly from, 22, whatever your room temperature is, all the way up to, I don't know, 300 or whatever the upper limit of your detector is, your probe or your melt temp device, whatever you're using. Instead, you go real fast. You go 1 to 2 degrees per second. You're not going to get an accurate melting point, but what you're going to get is an idea of, does it melt really low? Does it melt around 100, around 150, above 200? And then you do it a second time to get a more accurate melting point. We benefit from the fact that we know what to expect. We have 3 potential melting points to hit. And we are getting close to the third one. I just bumped it up a tiny bit again. Prior to doing the melting points, because I was taking some sample away, I did measure the mass. I almost said melt. That's not what I did. I weighed all the solids, so you'll see they are sitting on watch glasses. Those are the round glass discs that they are sitting on. I tared the watch glass and then I dumped the solid out onto it. Compound A, I did have to scrape off the paper a little bit, but for the most part, it came right off. Dry solids typically will come loose of whatever it is they're dried onto fairly easily. Wet solids will stick to the paper or the sides more. Watch your melting point, we're pretty close. B and C just fell right out off the paper. I had to do very little scraping with those. I measured them, I recorded that, I will post that along with some pictures for you guys. And we are just about done with our melting points. I believe by now all three should have melted. I'm gonna let it go a little past that point, because the last thing I want to do is redo a melting point. But by now it should be done. So you should have 3 melting points, one for A, one for B, and one for C. And then from there, you're going to use that information to identify its compound A. Acetanilide is unknown A. Benzanilide is unknown A. Benzoic acid. Do that based on its melting point, and then do the same for B and C. You'll have the masses, so you can calculate percent recovery, and then you'll just have a handful of questions to answer in the post-lab summary. So that's it. We officially have survived our first experiment. Next time we'll be doing distillation, which is great for liquids. So brush up on your boiling point theory. All right, thanks.